Okay, so to solve radical equations, the first thing you want to do is get the radical by itself, isolate it. So you have to get rid of everything that's not the radical. Then we will raise each side of the equation to the power suggested by the index. That sounds fancy, but it means you undo squaring with a square root. You undo square root with a square. You undo cube root with a cube, right? If it was a fifth root, you would raise it to the fifth power. And then check your answers for extraneous solutions, because we've already seen that you can get an extraneous solution. And then sometimes you might have more than one answer and only one of them will work. Sometimes you have one answer and it just doesn't work. All right, so let's do the first one. Actually, why do we want to do the first one? Let's do number 3. Then you guys can go back and do 1 and 2. Number 3 is more complicated, right? What should we get rid of first? What do you want to do? Get rid of the -6 or the -3? Which one?
The 3.
You want to get rid of the -3, and I heard a vote for -6. So I'm going to tell you that it's going to be easiest to get rid of the -3 first. If we wanted to get rid of the -6 first, we would have to divide this by -6, but also this, and also this, and we would end up with a fraction here. It would be a little bit messy. So you are allowed to do either. But I think it might be easier if we get rid of the -3 first. And how do we get rid of a -3? Good. I see a negative over here, so I'm a little bit worried, but we don't have it isolated yet, so we'll see what happens. Okay, so that -6 is being multiplied by the square root, so how do we get rid of it? Divide it, good. All right, so now, does our square root still equal a negative? No, so that's good news. So it might just work out fine for us. We might not get an extraneous solution. So let's do what to get rid of the square root? Square it, good.
Oh, yeah.
All right, what do we get? 0, good. All right, we're going to check it. Okay, so let's see if we do this, if we get -15. I have -6 square root of 4 minus 3. -6 times 2 minus 3. And -12 minus 3. Are we going to get -15? Okay, good. So just like I said, it's usually going to work unless we get into that situation where you have to square a negative number. So I'll give it a check to say I checked it and it's good. All right, I would like you guys to work on 1, 2, and 3, and I'll come around and see who needs help. Okay, I hear a lot of discussions and some of it's even math, which is super. Number 1, I saw a lot of people subtract the 5. And you had square root of x equals 4. And then what did you do to both sides? You squared it. Okay, squaring and square root will cancel, and we get x equals 16. Did you check your answer? Oh, thank you. Did you check your answer? Yeah, and it worked? Remember, I do want you to check your answer. Okay, so it did work. Give yourself a check. All right, in problem 2, remember we have to isolate the radical. 1, how did you get rid of the 2? That one right there. Right. All right, and then Morgan, how did you get rid of the cube root? Very good. So raise the cube root to the power of 3. Those are inverses. Three to the third is how much? 27. Good. All right, then you subtract the 7. And then what's our final answer? 4? Good. Who checked it? Sally checked it. Anybody else check their answer? Okay, please check your answers. Do that now if you haven't done it yet. Check. All right, cube root of 27. Did anybody do that in their head, cube root of 27? It is 3. That's good because 3 times 3 times 3 is 27. I want to show you how to do it in Desmos because it's not obvious. So if you're having trouble with roots and you want to be able to do cube root in Desmos, when you go here, they only have square root. But if you go to functions, you can go all the way down and there's your root that you can change. So you can change the index to 3 and then you can do cube root of 27. Okay? So you can do it that way too if you're struggling with that. I think at one point I had to do cube root of 343 and I was like, I don't know that. So I can do the same thing. If I want to do cube root of 343. Okay, and it's 7. But that's not what we're doing. We were doing cube root of 27, which was 3. So we had 2 times 3. And that does equal 6. So that means my answer checks out. All right, so number 4 was definitely one where we had a few issues. First issue was this is already isolated. Some of you were like looking for things to get rid of. There was nothing to get rid of. Our very first step is to do what to both sides? Square it. Good. So I'm going to square the x, and I'm going to square the square root. And then I got x squared equals 56 minus x. All right, now I saw a whole bunch of people wanted to get rid of that square now by square rooting both sides, but we would just end up in exactly the same place, right? Okay, raise your hand if you have an idea. I see 2 ideas, 3 ideas. Sky, what are you thinking?
Add the negative x to both sides.
Okay. Can you tell me why we're doing that?
So that there's x is only on one side.
Mm-hmm.
And so once you get a solution of the side with the numbers, it will just be equal to the variable, and then you'll have an answer.
Okay, so I think we are heading in the right direction. Can anybody tell me when we solve a quadratic equation, we're trying to get one side to equal what? 0. Good. So I'm agreeing about moving the x over here, but I'm also wanting to move the 56 over so that we can have one side that's 0. Okay? Did anybody move the 56 over too? Not yet? That's okay. We'll do that together, right? All right, so let's move the 56 also. And now I have x squared plus x minus 56 equals 0. Does this bring back memories? It does for a few of you. A few of you who haven't blocked that out. Okay, so what are some ways we can solve a quadratic equation? The multiplying thing. What is that called? We could do quadratic formula, right? What else could we do? The multiplying thing, which rhymes with tractoring. Factoring. We could do factoring. We could do quadratic formula. You could even graph it. Does anybody know how you would solve that by graphing it? Okay, that's not how I want you to do it, but I'm going to show you because it's good to have a lot of tools. Let me just show you the graphing one real quick. X squared plus x minus 56. All right, I want to know where that equals 0. Okay, so here's 0. Well, that equals 0 over here at -8 and over here at 7. So you can actually solve a quadratic very quickly by graphing it. However, in the past, like on tests and such, it said solve it by factoring, right? So you'd have to actually show the steps for factoring, or solve it by quadratic formula and you'd have to show the steps for this. But this is a really good check on your answers. So we already know that our final answers are going to be -8 and 7, but let's do factoring because I just love to review factoring. Okay, to factor this, we're in luck. There's no coefficient for the x squared, so we can start with x times x gives us x squared. And then how about the -56? We need numbers that multiply to -56 and add to what? -56 is the multiply, and what's the add number? You guys are looking at the right term. So yes, this is the term we're looking at, and the coefficient is 1. Thanks, Blaine. Okay, so what numbers multiply to make -56 and add to 1? Take a minute and think them up. Tell your neighbor if you get them, but don't tell everybody. All right, I'm hearing some people say 8 and 9. I think those are off. It's 8 and what? 8 and 7, okay. Which one's negative if I want to make a positive 1? It doesn't matter? Yeah, it matters. So if I put the negative here, I get positive 1, right? If I put the negative in the other place, I would get what? -1. All right, now, those numbers are not exactly the same as we had for the answers, but we're not done yet, right? Because we have to set each factor equal to what? 0. So let's do that. All right, so those are the numbers that I got by graphing. However, we're still not done because we have to check them. So -8 was not a solution. When I put in 7, I get 7 equals 7. So that means 7 is a solution because it works. So here, that one is extraneous and it's just the solution. We did all the steps right. It's just that we had an extraneous solution and that happens. That one was tricky because we didn't know we were squaring a negative number when we did the problem. All right, any questions on that one before we move on? Remember, you got to throw out the -8 and then keep the 7. Okay, other side. So here we have fraction exponents. Remember, fraction exponents are roots. For example, this problem right here, this one, 1/2 power is exactly the same thing as a square root. This means square root. Okay, if you want to, you can actually just change it to a square root to solve the problem. So something like that, you could just change it to a square root. And then solve the problem just like we did before. You can subtract the 8. Uh-oh. -5 makes me think that we're going to get an extraneous solution.
Will this also be on the test next week?
Yeah. Is that good news or bad news? I feel like this is easier than all the other days.
Yeah.
All right. So I'm going to get x equals 6, but I kind of rushed through it because I was having a feeling that it might be extraneous. Why did I think it might be extraneous? Yeah, because I squared that negative number, right? But let's check it. So I'm going to put it back in here. Square root of 4 times 6 plus 1 plus 8 equals 3. 4 times 6 is 24, plus 1 is 25. So square root of 25 plus 8 equals 3. I'm getting 5 plus 8 equals 3. Does it work? No. So that means that I'm going to throw out this solution, and there is actually no solution. I went through that one pretty quickly just because once I changed the 1/2 to a square root, it was very straightforward. Does anybody have a question on that? Okay. I'm going to do 7 so that you guys can go back and do 5. So let's look at 7 together. So x plus 3 to the 4/3, technically what that means is it's being raised to the 4th power and it's also a cube root, but that can be a lot to deal with. So I'm going to leave it as 4/3 so I can show you how you can deal with these exponents by themselves. So we are going to isolate this part. So what would be the first thing to do to get the parentheses part by itself? Subtract 4. Very good. Minus the 4. So now I have 32, and I'll bring everything else down. Okay, I still don't have the parentheses by itself. I have to get rid of what? The 2. Good. So let's divide to get rid of the 2. So I have x plus 3 to the 4/3 equals 16. Okay, so I don't want to have this exponent 4/3 there. What I really want the exponent to be is 1, because anything raised to the 1 power is itself. So what could I multiply 4/3 by to get an answer of 1? 4/3 times what would give me 1? Well, 4/3 times 1 is 4/3. Yes, Guy? 3/4. What do you guys think? If I multiply 4/3 times 3/4, that would give me 12 over 12. Is that 1? Yeah. So you're going to multiply by the reciprocal. Now, what we're really doing is raising a power to a power. I want to remind you that raising a power to a power, you multiply exponents. Okay? So what we're going to do is we're raising this to the 3/4 because that's the reciprocal. And then I have to do it on this side as well, to the 3/4 power. That's going to give us 12 over 12, which is 1. So basically that is going to cancel. Notice I'm canceling the 3's and the 4's. So now I just have x plus 3 on this side. That's lovely. And now I need to rewrite 16 to the 3/4 as a radical. Which of those numbers goes in the index here? It is the 4. Good. The denominator is your index. And the exponent goes out here. All right, I want you to take a minute and consider what is the 4th root of 16. The 4th root of 16 is 2. I still have to the 3rd power. All right, what is 2 to the 3rd? 2 times 2 times 2? 8. And then my last step is to subtract the 3. I'm getting x equals 5. Okay, now I have to check it, but you know what I'm going to do? I'm going to plug it in, and I'm going to use Desmos in my check just to save a minute. So to check it, 2, 5 plus 3 to the 4/3 plus 4, it should equal 36. If you have a computer up, I would suggest you also check it in Desmos because it's really good practice. If you don't have a computer up, feel free to open it. All right, 2 parentheses 5 plus 3 raised to the fraction 4/3. And then plus 4. All right, it got 36, right? That's what I was supposed to get. So it works out. All right, we skipped over 5. Why don't I give you guys a second to do 5, and then we'll do number 8 together. Or you can work ahead on 8. It's up to you. But do 5 first. All right, folks, I think you're doing great with this. So most of you realized that you needed to raise both sides to what power? 2/3. Good. So you're going to use the reciprocal because the 2's will cancel and the 3's will cancel here. So I just have x minus 27. And then I saw a lot of you guys convert this to cube root of 64 squared. 1, how much is the cube root of 64? 4, good. So we have x minus 27 equals 4 squared. 4 squared is 16. One thing I loved is I heard some of you defending your answers and you said, I checked it. So checking it is a very good way of defending your answer. All right, am I going to end up with 43? Okay, good. Bless you. All right, so when you check it, I don't mind if you check it in Desmos. It is important to check it, or you can do it with the steps. Did anybody check it with steps, or did you all just do Desmos? Did anybody check it showing steps? You did? Okay. So you can use Desmos, that's fine. You can also rewrite it because that square root there, that denominator of 2 gives you a square root. This gives me how much? 16? Is that right? Square root of 16 is 4, and 4 to the 3 is 64. So that means my answer is right. All right, can we do the last one? Okay, it's a word problem, but don't be afraid of word problems. Word problems just tell us that all this math is actually useful somewhere. So the sales of a certain product after initial release can be found by the equation sales S equals 19 root 4t plus 46, where S represents total sales and t represents the time in weeks after release. How many weeks will pass before the product sells 160 units? So I'm going to put 160 for which variable? Good, for the sales. So 160 equals 19 root 4t plus 46. All right, so I need to isolate the radical. What would be my first step? Subtract that 46. Does that give me 114? Yeah. Okay. And then how do I get rid of that 19? Divide it, good. All right, what does that give us? 114 divided by 19. 6. Thanks, Islan. All right, undo the square root with a square. Good. And then I'll divide. So time is equal to 9 what? Look at the problem. What does it say time is measured in? Weeks. Good. And I'll check it. Is that right? Hello. I feel like there's no square root of 4 times 19. So oh, 9 is 9. That's my bad. I was like, what am I doing wrong here? 4 times 9. That works. So 160 equals, this is 36, and the square root of 36 is 6. Okay, and if I do multiply these, I should get 114 plus 46, which is 160. Okay, so it works. All right.